In this video, I review the metric, apothecary, and household systems along with example problems utilizing dimensional analysis.
Welcome to RN Knowledge and thank you for checking out my channel. In this short video, I will be discussing systems of measurement commonly used in everyday nursing practice for medication administration. I will also touch on household and apothecary systems of measurement and go over single-step conversion practice problems. Currently, the metric system is the most widely used system of measurement and is considered the gold standard. Objectives of this presentation will include identifying common units of measurement, converting to metric volumes and weights, converting household units and converting corresponding units between both metric and household systems. There are three systems of measurement: metric, apothecary, and household. The apothecary system was used in the past dating back to the Middle Ages. Although this form of measurement is no longer utilized in current day practice, nurses do need to have knowledge of the system to be able to interpret the various units within the system itself. As far as current day practice, the apothecary is primarily encountered in historical context, serving as a reminder of the evolution towards a more precise and standardized use of measurement. The household form of measurement is primarily used in the home setting. In nursing care, this type of measurement involves familiar units like teaspoons, tablespoons, and cups. While it's commonly used by patients in the home environment, it does pose a risk due to the variability of units. The household system is not as accurate as the metric system. This illustrates the importance of standardization for patient medication administration. This table shows an example of units, the associated unit abbreviation, and its equivalent. You'll see 1 tablespoon is equal to 3 teaspoons, which is equal to 15 mLs. This is an example of a conversion between the household and metric system. The metric table is something that you will have to commit to memory while doing dosage calculations during nursing school and at the bedside. If you'd like to skip ahead to the practice problems, I have placed timestamps listed below. I have also placed a PDF link of a metric table for you to download to have as an added study resource. For the metric system, the basic units of weight and volume are based on the number 10, as in the decimal system. The metric system uses the basic unit of gram as the unit of weight and liter as the unit of volume. Here we have some common abbreviations and equivalencies within the metric system. In the metric system, conversion factors are always in multiples of 10. To convert from one unit to another, you will either divide or multiply. The rule is, if you're converting from a larger unit to a smaller unit, you multiply by the appropriate equivalency or move the decimal point 3 spaces to the right. This slide shows the example of multiplying by 10 3 times, multiplying by 1,000, and moving the decimal point 3 spaces to the right. The answer for each approach provides the same answer. 1 gram is equal to or equivalent to 1,000 milligrams. For this example, we are converting milliliters to liters. We are converting from a smaller unit to a larger unit. We can do this by either dividing by its equivalency or moving the decimal point 3 spaces to the left. Remember, when using liters, capitalize the abbreviation L as to not confuse it with the number 1. So some points to remember in order to reduce medication errors. A 0 is always placed before the decimal point if the unit is less than 1 whole unit. In this example, we have 0.29, not 0.29. Extra zeros to the right of the decimal point should be deleted. For example, we have 10.06, not 10.06000. Those trailing zeros after the 6 would be eliminated. Conversion factors are always in multiples of 10. To convert from one subunit to another, you will either multiply or divide. If you're converting from a larger unit to a smaller unit, you multiply by the appropriate equivalency, or you move the decimal point 3 spaces to the right. To convert from a smaller unit to a larger unit, divide by 1,000, move the decimal point 3 spaces to the left. Many students do struggle with their dosage calculations while in nursing school, but it does get much easier in time and with practice. If you've enjoyed this video, please give it a like and a share. And if you haven't, subscribe to my channel for more great content. As it helps my channel grow, it helps to reach a larger audience. Next, I will be going over single-step problems using dimensional analysis. These problems are simple conversions and can be easily solved in your head or by either dividing or multiplying like I referenced on the previous slides. However, for this portion of the video, I set up example problems using dimensional analysis to illustrate that this type of method is accurate and efficient for solving dosage calculations. Dimensional analysis equations are set up and solved in a fraction format, although these are not true fractions. All unwanted units are canceled out and we're left with the desired units remaining. Let's get started. Problem number 1. MD ordered 0.25 grams of a medication. What is the equivalent dose in milligrams? I set this problem up starting off with what the MD ordered, 0.25 over 1, or as a placeholder, times 1,000 milligrams over 1 gram. This is set up so our grams cancel and we are left with milligrams. Then we multiply across 0.25 times 1,000 milligrams and we get our answer 250 milligrams. The overall goal is to take a known quantity and multiply it by one or more conversion factors. This example is similar to number 1 as we are going from a larger unit to a smaller unit. The MD ordered 2 grams of a medication. What is the equivalent dose in milligrams? Set up the problem as what the MD ordered, 2 over 1, and we're going to multiply times 1,000 milligrams over 1 gram. The grams cancel out diagonally, and then we have 2 times 1,000 is equal to 2,000 milligrams. Problem number 3. The MD orders 0.125 grams of a medication. What is the equivalent dose in milligrams? 0.125 over 1 times 1,000 milligrams over 1 gram. You know this is the conversion factor based on our equivalence table, that 1 gram is equal to 1,000 milligrams, and we're setting up the problem so the unwanted units cancel. So the grams cancel diagonally and we're left with 0.125 times 1,000 milligrams, and our answer is 125 milligrams. With simple conversions, they can be calculated using dimensional analysis or by moving the decimal point. Either method is acceptable. However, when using dimensional analysis, you decrease the risk of making an error. All right, number 4. The MD ordered 6.5 milligrams of a medication. What is the equivalent dose in micrograms? We have this problem set up 6.5 milligrams over 1. We're going to multiply that by our conversion factor, 1,000 micrograms over 1 milligram. Our milligrams cancel out, so we're where we want to be in micrograms. We're going to multiply 6.5 times 1,000, and our final answer will be 6,500 micrograms. Problem number 5. The MD ordered 0.028 grams of a medication. What is the equivalent dose in milligrams? We have our problem set up of what the MD ordered over the placeholder 1. We're going to multiply that by 1,000 milligrams over 1 gram. Our grams cancel out diagonally and we are left in milligrams, exactly where we want to be. So we then multiply across 0.082 times 1,000 milligrams, and our answer is 82 milligrams. The next few example problems depict conversions from smaller units to larger units, which we can figure out by either dividing by 10 for each unit changed or moving the decimal point 3 spaces to the left. The MD orders 500 milligrams of a medication. What is the equivalent dose in grams? So we have 500 milligrams over 1. We're going to multiply that times 1 gram over 1,000 milligrams. Our milligrams cancel diagonally, and we are left with 500 times 1 gram. Divide that by 1,000, and our answer is 0.5 grams. Problem number 2. The MD orders 7,500 micrograms of a medication. What is the equivalent dose in milligrams? We set up the equation putting the 7,500 micrograms of the MD ordered first times the conversion factor of 1 milligram over 1,000 micrograms. Our micrograms diagonally cross cancel. Put the placeholder under the 7,500, but it's not necessary because these aren't true fractions. Cancel out the micrograms and we're left in milligrams. Multiply across 7,500 times 1 is 7,500. Divide that by 1,000 and our answer is 7.5 milligrams. The MD orders 4,000 milliliters of a medication. What is the equivalent dose in liters? We set up our problem 4,000 milliliters times 1 liter. Now I'm going to put the placeholder under the 4,000 mLs, and we know from our metric table conversion tables that 1 liter is equivalent to 1,000 milliliters. Milliliters cross cancel and we are left with liters. 4,000 times 1 is equal to 4,000 divided by 1,000 is equal to 4 liters. Problem number 4. The MD ordered 250 grams of a medication. What is the equivalent dose in kilograms? Set up the equation 250 grams over the placeholder 1. I'm placing the conversion factor. We know that 1,000 grams is equal to 1 kilogram. Our grams cancel diagonally. We then multiply 250 times 1 is 250 divided by 1,000. 0.25 kilograms is your answer. Thank you for being here and supporting my channel. If you found this video helpful, don't forget to like, share, and subscribe so you never miss future content, as your support inspires me to keep improving and delivering education that connects us all. See you on the next one.